Hello friends, welcome to Shikshathi. In this video, we will be discussing question number 1 to 3 of exercise 8.3 on trigonometry. So let's start. Okay, now before I begin with this exercise, we start solving the questions 1, 2, 3 of this exercise. I hope and I sincerely hope that you would have watched all the videos on trigonometry that we have done till date, because we are going to use all those concepts, and to be more precise here, we'll be using all these three tables. We'll be using this table and this table, right? So nothing, in this video we'll be basically talking about the complementary angle concept of trigonometric ratios. Okay, so now question number 1 is subdivided into 4 parts. Okay, when I say this is the first part, this is the second, this is the third, and this is the fourth. So all you are expected to know here is 18, don't see the trigonometric part of it as of now. Don't see the trigonometry in it, just see the angles here. Is 18 degrees plus 72 degrees equal to a 90? Yes. 26 degrees plus 64 degree equal to a 90 degree? Yes. 48 and 42 degrees equal to a 90 degree? Yes. 31 degree plus 59 degree equal to a 90 degree? Yes. Once you are able to see this is just like you are trying to see what type of a question is this. Once you are able to figure this out, now it becomes easier for you to attempt. And what are you supposed to do after this is use the complementary angle concept. So if I take a triangle like ADC such that angle A and C are complementary to each other, so what are we saying? We are saying A plus C is equal to 90 degrees. So use this PBH concept. Now this PBH concept says this along the diagonal you are getting a 1, and along the other diagonal you are getting a 1 in the center, right? And from here you are getting what? Sin C is equal to cos A. At the same time you are trying to say cosec C is equal to sec A. Very important. And you do not have to mug it up. And what were you supposed to do in this PBH concept is something that we did in part 2 of trigonometry. So do see that video. Okay. So can I say from here, now this is sine, this is just like saying, imagine this is 18 degrees. So in that case, this will be 72 degrees, right? So what will we get here? Oh, so when I recheck the question, this is not sine, this is cos. Right? Okay. Now can I say cos A, cos C, or let's say sin C is equal to cos A? Meaning thereby, can this be written as cos of 90 minus 72 degrees upon cos 72? Wherein we know that sin theta is nothing but cos of 90 minus theta. Okay, once you are able to establish this, or without even writing this, you could have said what? In a right angle triangle, if A plus C is equal to a 90 degree, in that case sine of A becomes equal to cos of C, or sine of C becomes cos of A. In that case, this becomes equal to a 1. Similarly, from here I can say tan C is equal to cot A. Let me just put this as tan A is equal to cot C. Can we say this? Of course. And similarly, if I am saying that this is sec C, can I say this is cosec C? No. So this becomes cosec A. So now how did I get this correct? I got this correct because in any case I need to get complementary angles. I need to get A and C. So coming back, tan 26 degrees is equal to cot 64 degrees. Tan A, let's say tan 26 degrees is equal to cot C, which is cot 64 degrees. So can I say this is equal to a 1? Yes. Now can I say cos 48 degrees is equal to sin 42 degrees? Yes. In that case this becomes a 0. At the same time, we can say cos of 31 degrees, cosec of 31 degrees is just like saying sec of 59 degrees. So this becomes 0. In short, when you are watching my video on complementary angles, you will see that in the first quadrant, we can say cos of 90 minus theta is equal to sin theta, sin of 90 minus theta is equal to cos theta. And from here you can establish the other trigonometric ratios also. So if it is true for sine and cos, then it will be true for all other trigonometric ratios, because here we are talking about the first quadrant. Because the moment you are saying sine of 90 minus theta, we are talking about the first quadrant only. Right? I hope you have understood this question. Let's move on to question number 2. So in question number 2, they are asking you to show that this, in the first question, this is equal to 1. The left hand side value is equal to a right hand side value which is equal to a 1. And the second question, they are asking you to find out that this expression is equal to a 0. So we will focus on the LHS. So let's say this is my left hand side value which is equal to my RHS, which is my right hand side value which is equal to a 1. So talking about the LHS now. So, and as we have learnt the complementary angles, we know about the complementary angles now, and we can use this table wherein if A and C are complementary to each other, in that case tan C becomes equal to cot A. So what will you say? You will say that tan 48 degrees can be written as cot 42 degrees. Right? At the same time, you can say tan 23 degrees can be written as cot of 90 minus 23, which is 67 degrees. So into this, into tan of 42 degrees, into tan of 67 degrees. Now if I take these two, these are reciprocals to each other. We know that tan theta is equal to 1 upon, so we know that tan theta is equal to 1 upon cot theta. Right? Okay, so if I use these two and if I use these two, multiply these two, so cot, so can I say tan theta into cot theta is equal to a 1? So which is just like saying cot 42 degrees into tan 42 degrees is equal to a 1, multiplied by cot 67 degrees into tan 67 degrees is equal to a 1, which is equal to my RHS value. So hence proved. Coming down to question number 2. So we know that cos, if A and C are complementary to each other, in that case cos A becomes equal to sin C, or sin A becomes equal to cos C, either ways. So can I say cos of 38 degrees is just like saying sin of 90 minus theta, which is 90 minus 38 degrees. So 90 minus 38 degrees is equal to how much? 52 degrees. Similarly, this you can put it as cos 52 degrees is equal to sin of 38 degrees. So how much is sin of 38 degrees? We need not know. We can just write it down as it is. And when we do this, and starting off with is LHS. So let us say this is the left hand side. So can we say LHS is equal to 0, which is equal to my RHS? And then you can write as hence proved. I hope this part is clear, and this is really very important. So this table is very, very important, which is why you were suggested that you should go through this video. Right? Let's move on to question number 3. So question number 3 is a good question, which says that if tan of 2A is equal to cot of A minus 18 degrees, in that case, find the angle A given that 2A is an acute angle. So the point to be noted here is, if you would have seen my solutions of the earlier exercises, also of the questions in the earlier exercises, I have always been focusing that the question should talk about the angle. What is the nature of the angle? Is it an obtuse, acute, reflex? What is it? It is mentioned in the question now. So this question can be approached in many ways, but I would first talk about the basic way of approaching this question, which says, now this is given to you. So I can use complementary angle theorem, which says tan of 2A is already given to you, right? So complementary can be used in two ways now. One is I can convert tan into cot, or I can convert cot into tan, but in either of the cases you are not going to get cot. So you can use any of them, or you can use both of them. So we know that tan theta is equal to cot 90 minus theta is just like saying tan A is equal to cot C. And we should know in that case, these two should be complementary to each other. I repeat, these two should be complementary to each other. Okay. Now, so what will we do? We will say that cot of 90 degrees minus 2a, given the fact that 2a is acute, this becomes tan of 2a only, can be written as cot of a minus 18 degrees. Right? Now I can cancel cot on both the sides because it is already given as acute. Now I can cancel cot on both the sides only when it is not like you just cut it across. You can cut it across only when it is given that this is an acute angle. Okay, once you have done this, in that case you will write this as this is 90 degrees minus 2a is equal to a minus 18 degrees. Now in that case, can I say 3a is equal to 108 degrees? So in that case, a becomes equal to a 36 degrees. So you get the value of a. This is one way of doing it. Another way here is, as I was talking about earlier, now it is already given that 2a is an acute angle. So let us try and understand this with the help of a triangle. And we are talking about a right angle triangle, right? So let's say this angle is 2a. In that case, one of the angle has to be 90 degrees. And the third angle has to be what? A minus 18 degrees. So without doing anything, you could have just said that these two angles would be complements to each other in a right angle triangle. Why? Because they have already given that 2a is an acute angle. In that case, you could have avoided all this and you could have used complementary angle concept of a right angle triangle, in which we are talking about all the angles being, now this is a right angle acute right angle triangle. So in that case, since this is an acute right angle triangle, we can say that 2a, can we say this? Can we say 2a is equal to a minus 18 degrees? Can we say this? No, we could have said this. Now, when I'm saying tan 2a is equal to cot of a minus 18 degrees, so in that case, please try and understand that this is my perpendicular, this is my base, and this is my hypotenuse. So if I'm saying tan a, so I'm saying what? Perpendicular upon base, and at the same time I'm saying what? So tan of 2a, let's say, becomes equal to perpendicular upon base. Now this should be equal to cot of a minus 18 degrees. You can check it out from here. So if I say cot of 18 minus a minus 18 degrees, cot theta, let's say this is theta, is equal to what? Base upon perpendicular. So this is correct. So the point that I'm trying to make here is, now can I say that the sum of these two angles should be equal to a 90 degrees? And you get the same answer. Right? I hope this is clear. Right? Okay. If you feel that this video has been really informative and it told you certain facts which you were not known to you, or you knew them but you could not have used them until they were reminded of to you, okay, so in that case, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. If you want us to do some videos on specific topics or difficult topics, please do not hesitate and let it be known to us in the comment section. Thank you so much. Until next we meet, goodbye.